West Monroe has established an AI-powered conversion approach to accelerate legacy report and extract conversion processes from SSRS and SSIS to modern technologies. We assessed each step of a typical report or extract workflow and built out a solution for 3 areas where AI could be integrated directly into the workflow to reduce time and effort required by a developer. In this demo, we will show the first 2 of those steps, documenting the code that needs converting and completing the code conversion. This demo will walk through an example migration of a relatively complex SQL stored procedure to PySpark functions for Databricks. This approach resulted in a 70% reduction of effort for this example. Now, let's walk through how we did it. Starting with step 1 in the workflow, a user will need to provide some configuration parameters to start. As can be seen at the top of this notebook, these include the desired API endpoint provider. This can be Databricks or OpenAI. Parameters related to the storage of source code for the stored procedure, which is the source file name, source folder path, and storage format. System prompt and user prompt prefix to send to the LLM. The preference to save the conversion response to a Unity catalog table. And finally, the LLM model name to use for the code conversion. This can be DBRX, Llama 3, or GPT-4o. For this demo, we're going to run the conversion using Databricks as the API endpoint provider and the Databricks DBRX instruct model. The notebook will read the source code from the file. This is done via the function fileRead. Then, moving into step 2, code conversion of our workflow. The notebook will format the prompt, submit the query or chat completion request to the LLM model endpoint, and get an LLM response back. This is done via the function getLLMResponse. One callout in this step is that this is where the selected API endpoint and model come into play to determine where the chat completion request will be sent. If it's Databricks, it will be sent to Databricks LLM endpoint. If it's OpenAI, it will be sent to Azure AI endpoint. Both are created within our Azure account or Databricks workspace. If we don't want to save the response to a Unity catalog table, the response will be displayed on the screen. In this case, we do want to save the response, so the response, along with some of the input parameters, will be saved to the default Unity catalog table. This is accomplished via the same function getLLMResponse_proc. A developer will now assess the AI-generated code conversion and modify and debug until satisfied. During this demo test case, the developer determined that were 2 modifications that needed to be made to finalize the code. These modifications took the developer about an hour compared to the 8 hours it took the developer to convert this notebook manually. The final part of step 2 in our conversion workflow is unit testing. A set of reusable prompts have been written that enable the user to populate a parameter for which notebook we want unit tests generated for. The notebook then uses an LLM to create unit tests. The unit tests are then run against the finalized code conversion. As we can see, all 8 unit tests passed, indicating this code is ready to be finalized and the output is ready to be tested. West Monroe estimates utilizing an AI-powered approach within the conversion workflow can accelerate current state analysis by 80% and can accelerate the code conversion by at least 50%. In the next video, we will showcase the AI-powered approach to code delivery and test case generation. Huge thanks to this team for building out this approach and demo. Looking forward for more to come.